Hi there everyone. Today we're going to have a look at what we call arithmetic series, and we're going to look just for the IGCSE. So let's start with something we should already be comfortable with, and that's finding the nth term of linear sequences. So please, if you like, pause the video, have a go, or if not, I'm going to explain it to you now. So the secret with these really is finding the link to a certain times table, and you can see here we have this common difference of +2. And that goes all the way through this sequence. That's because it's a linear sequence. So we can have questions that these change, but it's not linear. Now, what else goes up in +2s? Well, that's the 2 times table. So we have 2n. So the 2 times table, I just glossed over that. So instead of writing the 2 times table, we write 2n, and the 2 times table is 2, 4, 6, 8, 10. So hopefully you can see that there's a difference of 3, and the sequence we started off with is 2n with 3 added on. Now, a common technique to do this, because it's super easy, if we go back this way, you can see you're taking away 2 every time. And so that's always how we can also get that term there. So if we take away 2, or take away 3 if it goes up in 3s, we'll always get this constant term on the end. So 2n plus 3. That's very basic. Now, the thing is, we're going to look at it a bit harder and we're going to add those terms together. So first, what we need to understand is what we call an arithmetic sequence. And I just glossed over that again, but this is an arithmetic sequence because it's going up by a constant difference. So if we call this one A, this one would be A plus the difference. So we say the first term is A, our second term is A plus D. Then what do we get in our third term? Well, we add on another difference again. So we've got A plus D plus another D, but obviously we would write that as A plus 2D. And then we keep adding on more differences, and that keeps on going until we reach the end. So if we start with the last term, we just need to start looking for patterns. So if this is the first, this is the second, then we have the third, then we have the fourth, you should be able to see there is one difference less than the number of terms, so we can write it like this. Now if we go back, you can see the number of differences drops down by 1, so the penultimate term would be n minus 2d's. Okay, so this is a general formula, and I've written it a bit tidier here. Now the great thing is the nth term is also this formula. So we can use this formula to find the nth term, but to be honest, with the linear ones, it's quite often easy just to look at it and write it down, especially if you've become fluent from the earlier years. And if you haven't already, we're going to start using this notation to represent nth term. Don't write nth term out. We use this, n for obvious reasons, nth, and the u probably because it's just upside down, looks nice. I don't know why. But we often use this u symbol when we're looking at sequences today and in future videos. So then it comes to this question. Well, how about the sum of the first 10 terms? Not just write the nth term. That could be pretty easy, couldn't it? We could just continue for another 5 terms and add them up. But what if it was 100 terms? What if it's 1,000 terms? What if the sequence was a little bit harder? It could involve negative numbers, for example, and that would be a bit trickier. So what we're going to do is learn a little bit about this mathematical legend. Okay, his name is Carl Gauss. He's a German mathematician, physicist. You can see the dates he was born there. And he is famous for what I'm about to teach you. So I think I wouldn't be doing my job properly if I didn't acknowledge him and show the journey that he went on to get this. This part of the video you can technically ignore, but if you follow it through and understand it, it's going to be a lot better for your attention. I like this as well. He was born, his mother couldn't read and didn't even record his date of birth. So he actually worked out his own date of birth because he knew a little bit of a fact, and it was where is it here? 8 days before the feast of the Ascension, which is 30 days after Easter. But Easter changes every year. So as a young man, he worked out when Easter was going to occur in previous years, and look at the dates that we're talking about. You can't just Google this. And he worked out his own birthday. And even when he was 3 years old, he was correcting maths that his dad had done. And you can imagine teaching this person, it would have been a nightmare. But at age 7, is it a rumor? Allegedly, his teacher gave him a problem just to find the sum of the first 100 numbers, just to keep him quiet for a little bit, so she could focus, or he could focus on the other pupils in the class. And it took him a matter of minutes to do it. And we're going to go on that journey. So just want you to appreciate the complexity of this problem. So he's having to work out 1, add 2, add 3, add 4, all the way up to like 100, okay? So you can try and think about that now and pause the video, but this is age 7. You're probably 15 or 16 watching this, and this took him minutes, and it led to a formula we're all going to learn about. So let's do that now. I'm just going to get rid of all of that actually. So this is what he did. So let's use an S for sum. So I'm just going to write that out again. Probably just should have moved it over, but I didn't. So this is how he started to do it. He didn't obviously start counting because he's a mathematical genius. What he realized, well, if you do it backwards, you get exactly the same result, obviously. But then something more interesting happened. He noticed that all the pairs equaled the same number. So if we add these up, we get loads and loads of 101s. So then he called this one 2s because we're adding s plus s. Well, then how many of these 101s would we actually get? So I'm just going to put all these pluses in here and just do it all nicely. How many of them would there be? Well, obviously 100. So what we have is 2s is equal to 101 times by 100. Remember, multiplication is a fast way of adding over and over again. So that's pretty easy. So 2s is 10,100, and then we can just half it. So we get 5,050. So age 7, to be given that problem, work it out in minutes, I hope you agree, is pretty impressive. Well, that later led to us, or him, writing it down as a proof, because what if it wasn't 100 numbers? You don't want to keep doing this all the time. If it was 1,000 numbers, or if this number's not starting on a 1, for example. So he wrote a formula. So instead of calling this number 1 and this 2, this 3, he used the general form. So let's just make a new, in fact, let's make a new page. Okay, so the sum would be a plus d. I'm going to put that in brackets so it's just a bit clearer to see. So then we have a plus 2d's, and this is going to continue on until we're going to get to the penultimate one, which is a plus n minus 2d. Put a big bracket around that, and a plus n minus 1d. And if we do it backwards, we get the same problem. So we're going to get a plus n minus 1d, the last term, plus the penultimate, so it's meant to be a 2d in there. Close that off. So let's do a plus, the one before that would be n minus 3d's. And that will continue on until we get to a plus d and then a. Okay. So if you remember, when we added these, we got exactly the same value. So 2s, well, what do we get when we add an a to an a plus n minus 1d? We get 2a's plus n minus 1d. Plus another 2a's plus n minus 1d. But how many of these would we have? Well, if there was 100, we'd have 100. If there were 50, we'd have 50. So let's say we have n numbers, so we'd have n lots of 2a plus n minus 1d. So therefore, s would be half of this. So because it's multiplication, we can either half here, or just half the total. So they decided to write it like this because it looks a bit neater. So n over 2, lots of 2a plus n minus 1d. N being the number of terms, a being the first term, and d being the common difference. Now there's another variation on this, that we can use, because all this stands for here is the first term plus the last. So sometimes you'll see it written as the first term plus the last term, but we can only use this formula if we have the last term. So you can kind of ignore all of that unless you're going to take your maths journey a bit beyond GCSE. It's really important to try and get to grips with this now. But you are given this formula in your test, but I would urge you to learn it. And you're not given this one, and it may make your life a bit easier in certain problems. So also remember that one too. So let's just go back to that simple question at the start, and then in another video we're going to look at some more complex ones that you'll find at the back of an IGCSE paper. So if you want to find the sum of the first 12 terms, so let's write out the formula, and always write out your formula every time. Okay, so we want the sum of 12 terms, so 12 divided by 2 is 6. We want 2 of the first term, which is 10. N minus 1, so it's 1 off the number of terms, 12 terms, so that's 11. And we're going to times that by D, the common difference, which is 2. So let's tidy it up. We have 6 lots of 22 plus 10, so that's 32. And that's 192. Easy when you know how. Let's do the sum of 100 terms. So I'm not going to write the same formula out again because I've got it there, so we'll just skip to this line. So sum of 100, but I know it off by heart, so I still would urge you to do it. N over 2, so how many terms divided by 2? So we have 50. 2 ways, well that's still 10 because it's the same sequence, plus N minus 1, this time it's 1 less than 100, so it's 99. And we're going to be timesing that by the common difference, which is 2. Now, the first one I was happy with. This one I'm just going to bung in my calculator really quickly. And we get 10,400. Okay, so today it's about practicing some simple versions of that. What you could have done actually as well to get these answers using the other formula. So the nth term is 2n plus 3. So what would be the 12th term, for example? So the 12th term is 2 lots of 12 plus 3, which is 24 plus 3, 27. So just to show you, if you use this formula, n over 2, a plus first plus last, so the sum of 12 would be 6 lots. The first number is 5, the last number, the 12th term, was 27, and you'll find that 32 times 6 is also 192. A little bit longer to use the shorter formula, so I wouldn't bother in this instance, but I'd only actually ever use it if I was given the last term. Okay, so hopefully that video makes a lot of sense. Please remember, you just need to know how to find this formula, which will be given to you, and just pop the numbers in, so it's actually a very easy topic. Best of luck!